Happy to be here and looking forward to getting to chat with many of you and whatnot. So, as was mentioned, I'm going to be talking about Gatekeeper and OPA Open Policy Agent if you're not familiar with it. And with that, I'm going to go ahead and share my screen and we'll cut over here. Okay. So again, I'm at Virginia Tech. Hopefully, I don't know at what point it cut off. So if we've got some Hokie alum, glad to have you here as well. And if you're not, that's okay too. So, all right. So about me, I've been full-time here at Virginia Tech since 2011, right after I graduated, finished my undergrad. And I've worn a lot of different hats over the years here. Developer and cloud has been a lot of my focus. And really, I would actually say a lot of my focus is really around how do we use computing and use them in a way that lowers the barrier of entry for others. So especially for DevOps and there's just a lot of tooling out there, and it's hard to keep up with it. So how do we make it easier for people to use? And we'll see examples of that as we go throughout this. I am an adjunct faculty instructor with the CS department, and I'm actually teaching a class this semester on Kubernetes, which is pretty awesome. So we've got about 60 students learning Kubernetes and whatnot. So if anybody's hiring or wants to hire some students, reach out to me and I'll be happy to put you in contact with them. So I don't know if I'm allowed to say that, but whatever. They can reach out to you. I also am involved with the community quite a bit and family guy, also my 5 kiddos. In case you're wondering, this picture is from DockerCon 2019. And I did a talk called Container for Beginners, and I just like to have fun. And my talk was one of the higher rated ones. And so I was invited to give it again on what they call the replay day. And don't ask why, but I had an inflatable dino suit in my suitcase and I brought it with me there. And since those replay talks aren't recorded, I decided to walk up stage in a dino suit and start giving my talk in the dino suit. And it was hilarious, but no visibility, and it's really hard to type on the keyboard through it. And I figured out the perfect segue. And it was like, busted out of the dino suit. I'm like, sometimes we have to put away the old things in order to do the new. And it was just a perfect segue. So anyways, that's just a little bit about me. If you do want to follow me on social media or whatnot, I'm MikeSir87, pretty much everywhere. So MIKESIR87. All right, enough about me. So here's what we're going to talk about. Why do we care about Gatekeeper and OPA? Why did we get interested in that? We're going to talk about some of the built-in Kubernetes mechanisms, and then where they fall short, and then how Gatekeeper and OPA kind of fill that gap. And then finally, we're going to talk about how we're applying it at scale here at Virginia Tech for our platform, which I'll talk about here in just a second. Okay. So first off, why do we care? About a year and a half, actually it was about 2 years ago now, we internally had what we called a process improvement initiative cycle going on, in which really anybody could propose ideas for kind of radical or new processes or things that we want to do that would better IT and better the university. So I proposed this idea to create an organizational unit that provides application technology infrastructure and shared services for all application development teams in the division, so the central division of IT, and then provide it as a service to all. So all of the colleges and departments and other development teams, et cetera. And the original goals was we want to be able to leverage a single common platform to run our applications. Those of you that have ever worked in a higher ed institution know that things are very Wild West. Anybody can hire a student or get a small little application written, and then it's probably running in a server or a computer in somebody's closet, and it's not being maintained or patched or updated anymore. The student retires. And so it's like, how do we keep that system safe and protected and maintained, recognizing that the person that wrote it is long gone? So that's a lot of the things that we're trying to solve. How do we provide some consistency? Because it helps recruiting and retaining and training and all those big buzzwords as well too. So so that's what we're trying to work on. And in human terms, at the end of the day, it's just we just want to be able to deliver faster and respond quicker without having to train everybody how to be a cloud engineer. And so I'll let you read the text here, but that's really the end of at the end of the day what we want to do, so that we can leverage cloud without everybody having to be a cloud engineer. We want everybody to be able to use containers without having to be a Kubernetes expert. or in a swarm or any of these other things. So how do we build a platform with the right levels of abstractions to let people move quickly? Okay. And this final bullet point is something that we really have been focusing a lot on. We want to design with multi-tenancy from the start. We've had previous efforts. We used Docker Enterprise back when it was a product sold by Docker, and it just didn't really quite work in a multi-tenant environment. And so that's something that we've been really, again, focusing on. How do we run Kubernetes in this case in a multi-tenant fashion that's safe? And I know that's scary to think about. Okay, so this is kind of what it looks like now. Of course, this is the 5,000-foot view. We've got our load balancers. Let me get the laser pointer down here. Boop. Okay, so we've got a load balancer that's just throwing traffic into the cluster, and then we are basically creating node pools. We're using AWS EKS for the control plane, but then we have node pools for each of the different funding or organizational units, and then within each of those node pools, people can run pods, and then we've got cross-account role assumption to let them access other AWS resources, however they whatever resources they might need at that point too. So now, again, that's super high level. There's a lot more behind the scenes and whatnot, and we'll talk about some of those things of how we provide isolation between the tenants. But for the most part, the split nodes or the split node pools are mostly for cost accounting, but also for another security isolation boundary there as well too. So when we think about multi-tenancy, every tenant needs to have its own namespace in Kubernetes, and that provides some barrier of isolation. And we'll talk about where that breaks down in a few minutes. And in our case, we're defining tenant really loosely. So a tenant could be an application. It can be an environment within an application. So for example, one of our teams that has a customer portal, they have production in one tenant and then all of their feature branch development happening in another tenant. While other teams have decided, well, we want all of our development stuff in one tenant and all of our staging and prod in separate tenants as well. So we don't impose how they use their tenants, and we're certainly open to letting them have as many as they want. Okay. I mentioned already that the node pools are mostly a cost accounting function, but they also provide additional security boundary. And we're heavily, and I mean heavily, using Flux for all of our GitOps and doing some pretty cool stuff with that. I've got other talks that I can do that are in that space, but Flux makes it really easy to let our tenants be able to define the things that they're doing. Okay, so when thinking about the built-in mechanisms and the support for multi-tenancy with Kubernetes, there's quite a bit there, but we'll see that there's quite a bit lacking as well. So let's talk about what's there first. So obviously Kubernetes has the concept of namespaces, and in case you're not familiar with it, it allows you to carve up your cluster into smaller virtual clusters. Okay. And so I can define resources into one namespace, and then somebody that's in another namespace, we can make it so that they can't see those resources. And again, it allows you to isolate things. And the RBAC allows you to control who can do what within the cluster. In case you're not familiar, the RBAC mechanisms in Kubernetes have no way to support authentication to let you know to how do you authenticate people. And again, that's a whole different discussion, but it has a very rich support for authorization of what you're allowed to do. Okay. And the way that it does that is using roles and role bindings. And then there's also roles, cluster roles, role bindings, cluster role bindings, which we'll talk about here as well. So a role, simply think of it as it's the permission set. Okay. So it's the policies and permissions for which you're able to, the operations for which you're allowed to perform. And on the next slide, we'll see an example of one actually being defined. The difference between a role and a cluster role is basically the scope for which that thing is visible. So a role is defined within a namespace, and so only things within that namespace can access it, while a cluster role can be defined at the cluster level, and then you can use it either within a namespace or across the entire cluster. And the reason you might want to use a cluster role and scope it to within a namespace, and we use this exact use case, is a platform tenant. We want to make sure that all of our tenants have the same set of permissions across the cluster. So we have a cluster role that defines what it means to be a tenant. Okay. but then we use role bindings to bind that cluster role, that cluster level or cluster defined role, but bind them to specific namespaces. Okay, so the role binding will grant a subject the rights to a specific namespace, while a cluster role binding will grant the access across the entire cluster. Okay, and I fully recognize that if this is the first time that you've heard this, it may still be a little confusing, but the first time you play with it, it'll make sense. Okay, so here's an example of one. On the left here, I'm defining a cluster role. Again, it's defined at the cluster level. I can then use it in any namespace or grant access across the entire cluster. In this particular role, I'm naming pod reader, and it's going to grant get, watch, and list permissions to pods. Okay, so I can't create, I can't delete, I can't update, but I can get, watch, and list. So it's basically a read-only role here. Okay. What I've got here on the right is then a role binding that's going to say I'm going to associate this cluster role, so the cluster role pod reader, in any the subject, so any user that's in this group OIDC platform example admins. So any user that's in that group will have the ability to get, watch, and list pods within the example app namespace. Okay, so if I'm in another namespace, the default namespace or a cube system or whatever else, I don't have permissions to do that, at least based on these two manifest here. Okay. Now, so the problem is that, well, those verbs aren't descriptive enough. Okay, so the policies limit the actions you can perform, but they just don't get granular enough. Okay, get, list, and watch. Okay, that works. But if I just grant the access to create, that can be pretty broad. I can create services. That's cool. But should I be able to create node port services or load balancer services? Okay, so again, going back to our goals to build a platform, we want to control the ingress. And so we don't want our tenants to be able to define load balancer services whenever they want. So how do we do that? We still want them to be able to create cluster IP services, but not load balancer service. And the RBAC mechanisms just don't give us that. Okay. And this last point, the pod security policies aren't enough. And there's whole other discussions that go along there. The PSPs are also going away too. But what specifically mean by this is, a pod security policy may be in place to say a pod can't mount a host volume. Okay, so I don't want a tenant to be able to mount the entire host file system into their container and be able to inspect things. But that happens at a pod level. If somebody's defining a deployment, the deployment will get applied successfully, but that PSP doesn't get blocked or doesn't block that pod until the deployment tries, or technically the replica set tries to create the pod itself. So then as a tenant, now I'm confused of like, why is my pod not starting? The deployment got created successfully. Why is this pod not starting? And so how can we kind of enforce those PSPs anywhere that pod specs are inlined? So like a deployment. Okay. So there's lots of different ways kind of around, or it's not quite enough granularity with the built-in mechanisms. Okay, so the way that Kubernetes still supports this and provides the opportunities to fix it is through what are called admission controllers. Okay, so the API request process looks something like this. A request comes into the API. The request is authenticated, authorized. Are you allowed to make the change that you want to do? There can be various mutating admission controllers that can look at the object and add annotations or labels or other pods or sidecar containers. What basically can mutate the object. Okay, then object schema validation occurs to make sure that the object is still valid. And then there's a set of validating admission controllers that basically say, hey, should this change be accepted? Okay, and that's where we can start to answer some of these harder questions. Okay, if all the admission controllers say, yep, this thing's good to go, then it gets persisted to etcd or whatever backing store your cluster might be using. Okay. Now, so these admission controllers, that's actually how Kubernetes does its own validating of things. The namespace exists controller is one that's built in and ensures that if I try to define a pod in a namespace that doesn't exist, well, this controller says, you're not allowed to do that, and it stops the request. Okay. And there's lots of other ones. In fact, as the bottom of the slide here says, there's 17 enabled by default on new clusters, and that's constantly growing and changing as new capabilities and new features are added to Kubernetes itself. Okay. What's cool though is that Kubernetes thought, people may want to put in their own emission plugins, or want to add their own policies on what should be allowed. Okay, so Kubernetes includes a webhook mechanism where you can basically register a webhook and say, hey, anytime a request gets created, notify this service. And this service will then look at the request and decide should that be accepted or not, and will return a response accordingly. And we'll see that here in just a second. These services are required to use HTTPS. And as noted here, if you're running your own emission plugin, be careful. Okay, it's part of the control plane. So if your emission controller starts dorking up and you 9 requests, well, you could basically lock yourself out of the cluster. So just be careful. Okay. And the way that we define webhooks is using another object called a validating webhook configuration, which an example is right here. Okay. So this is saying I want to define a validating webhook configuration. And so any requests that are going to the V1, vBeta 1 API groups, I'm going to notify this service. So in the example namespace, I'm going to send a request to example service, and we'll see on the next slide what that request actually looks like. In this case, we're using Cert Manager to inject the CA, and then the app would actually be using a certificate from Cert Manager just to have that HTTPS connection. So that's what that annotation is there. And so once I define this, then I can plug in, I can define an application, and anytime that a request is being created, updated, or deleted, basically mutation objects, the app will receive this request, and it's an emission review, and it contains a lot of stuff like the request and request kind, the user info, the actual resource and object. If it's an update, you'll get the old object. So if you want to do diffs, you can do that. And then based on whatever policies or whatever configuration you define, you return whether it's allowed or it's not allowed. In this case, you could say you can't apply this change because it's a Friday and your name starts with an A. So you can come up with whatever kind of crazy policies it is that you want. And this emission review process and webhooks allows you to kind of insert yourself into that validation chain. So super powerful. Okay. Now, while it's cool to be able to do that yourself, you probably don't want to do it yourself. Okay. Because again, as part of the control plane, you want those requests to respond quickly, and you also may want to leverage other policy engines and that kind of stuff. And OPA and Gatekeeper come in here to help out with that. Quick drink. Okay, so OPA and Gatekeeper. OPA is a policy-based control for cloud-native environments and allows us to define basically policies using a language called Rego, which I'll admit is a little funky and is a little hard to wrap your head around, but that's okay. And OPA is used in many different environments, and Gatekeeper is basically a wrapper for OPA to run in Kubernetes. And what it does is it runs the OPA engine, but then also runs a web server to be able to serve as that emission controller. So it will receive the request, pull out the pieces, and then pass the context to the policy engine and run things. And another really cool thing about Gatekeeper is it allows you to define your policies through Kubernetes objects. And we'll see examples of that here in just a minute. So I can define my policies. Gatekeeper will ingest that, put it into the OPA engine, and then the next request could be validated by the policy that you just defined. Okay. So here's an example of an OPA policy. Again, it's written in Rego, and the way to read Rego policies is basically a series of truth statements. Okay, and if a statement is truthy, then it moves on to the next statement, and you keep going until you hit a false statement. Okay, and once you hit a false statement, then the function basically returns and stops. So the way to read this is if we get through this entire block, this thing is going to be denied. So this is a deny statement, and we're going to deny only if everything in this is truthy. So we look at the input .request, and again, this is going back to that object that we received through the webhook. So if the kind is a pod, what we're going to do is we're going to look at the object that's part of that request, pull out all the containers, so spec.containers, and this is going to start doing an iteration. So basically from this point on, it's going to do execute each of these commands once for each container. And again, it takes a little while to wrap your head around. So image is both an array, but also it's a single instance. It's iterating through it. So again, read this as we're going to pull all the images from the containers. If any of those images don't start with, in this case, myregistry.com, we're going to set a message in any sort of assignments. Those are truthy. So we're going to set a message to say image comes from an untrusted registry. So this would be a policy that would say, I'm only going to run container images that come from this registry. Okay. And so again, what Gatekeeper allows us to do is define our policies using what's called a constraint template. And we're going to do an example of one. And I forgot to update this one box, but we've got a policy that we call an authorized domain policy to say what domains are authorized for a tenant to be able to use. Okay. And so we define that constraint template. It goes into the Kubernetes API server, and then OPA or Gatekeeper sees that constraint template, loads it into the policy engine, and I can start using it. Okay. And what actually happens behind the scenes is when I create a constraint template, then it creates another CRD that allows me to create ingress allowed domain objects with different parameters. And we'll see an example of that when I do a demo here in just a minute. Okay. And so this is an example constraint here. And this isn't the one that I'll show in the demo. The one that we have is a little bit longer than this because we also validate the certificate objects themselves. But this is just one that will fit on a slide. So this is an ingress allowed domain. And the reason that we want this policy is if we want to allow our tenants to be able to define ingress objects, we want to make sure that they are only defining ingress objects for the domains for which they're authorized to use. I don't want tenant A to define an ingress that would basically intercept the traffic of tenant B. And so what we do is we create this policy, and then we create the ingress allowed domain objects that basically say, here are the authorized domains for your namespace. Okay. And so what this does is a violation would say, if the object is an ingress, grab all the host, grab the parameters, domains, and that's something that Gatekeeper allows us to do, which we'll see here in just a minute. So get the authorized domains and then basically match them and find out is the ingress on the or is the host on the ingress in the authorized domain list. And we also like support wildcard and that kind of stuff too. Okay. And then this is how we actually provide this parameter. So again, the constraint template is basically saying, here's a template for a constraint, here's the policy for it, but it's not until we actually create the object and specify the namespace and the parameters for it that it actually puts the policy into the engine. So in this case, what this would be saying is that for the example app namespace, they're allowed to use app.localhost for a domain name. So if they use anything beyond that, it's going to get denied. Okay. So applying this at scale, like I talked about earlier, we are trying to do this for all of our tenants in our platform. And as of right now, we have we just kicked off a workshop yesterday that had about 35 participants, and each of them had their own tenant namespace. And beyond that, we have about another 20 tenants. So we've got about just over 55 tenant namespaces that we're leveraging right now. So the way that we do this is kind of building on the whole tenant idea, and this is a college town as well. We built a Helm chart called the landlord, and the landlord's in charge of defining all the tenants and making sure that they're ready to go, and provides all the right configuration for it. And this is an example of what it looks like. So it has a tenants array. We give an operator array group that goes into the RBAC mechanisms, but here are the domains that they're authorized to use, node affinities. So we actually mutate on to each of the pods within a tenant namespace to say, here's the node pool that you're allowed to use, and it forces them into that node pool so that they only run in their node pool. So we do that. Now, time to do a demo here. And what I'm going to do for this demo, and this is fully available to anybody else that wants to try this out, is, let's see, Gatekeeper. I accidentally closed the tab, so I'll pull it back up here. We're going to run through this real quick, and what we're going to do is we're going to run some setup, and that's going to install all the Gatekeeper stuff, all the components there. We're going to install the actual constraints, and then we're going to install a landlord and and try breaking it here. Okay, so this is that repo, just clone locally. And so I'm going to just apply the setup. This is going to install Gatekeeper and all the CRDs, and also have traffic just for some as a Ingress controller here. And now what I'm going to do is I'm actually going to install my Gatekeeper constraints. And I'm just going to use the local chart that I've got here. And what I'll show what that looks like here. So that chart, I've got a Rego policy here that is doing exactly what we were just talking about, this authorized domain policy. So we're going to validate the ingresses and certificates if we're using them, and validate that we're authorized to use that. Now, the reason we actually split the Rego out into its own file to write tests for it, and I've got the test here, and so I can actually do an OPA test and test against that policy and validate that it works in all the different ways that we want to. Okay, so let's go ahead and install our landlord. And while it's doing that, I'll show that real fast. So our landlord chart has a values YAML that's going to create a tenant namespace called Hello World and authorize that tenant for hello world.localhost. And the way that it does that is we've got a template here that is going to create a authorized domain policy object, which got created, that CRD was created by the constraint template earlier, and it's going to authorize the domains that are specified in the values YAML. Okay. And so that's how that's working. All right, so at this point, I'm going to go into Hello World, and in here, I've got a couple different applications, and we're just going to, actually first, let's see the namespace. We see that Hello World is here. It was created just 43 seconds ago, and I'm going to put all this into that namespace. And oops, that's all right. I should have just done it with the customization, but that's okay. Everything got created. And if I look at my pods, I'll see the ingress is there. That's great. Now, if I try to change my ingress to, bad hello world, and when I try to apply this, it's a pretty nasty message here, but it tells me that the admission controller denied the request unauthorized host on ingress bad hello world.localhost, because that wasn't one of the authorized domains for my application or for this tenant namespace. So again, pretty quick demo here, but it allows us to extend the capabilities of the Kubernetes RBAC system and be able to add our own policies, our own capabilities, and the things that we want to do. So with that, I'll just throw this slide up here. I won't go back full screen, but Gatekeeper has its own library for a lot of Rego scripts and a lot of common practice things. This is just an example of one of our policies, but we've got policies that do a wide variety of things. We implement the pod security standards and the authorized domains. We block node ports and service load balancers, and quite a few other things as well too to keep things safe and protected for our tenants too. So. And with that, thanks again. And if you've got questions, I'll be looking through chat and kind of catch up to things. But feel free to reach out. Feel free to look at the demo here. And I try to be pretty accessible and answer questions. So feel free to shoot me an email or hit me up on Twitter or whatever method you want. And with that, I say thank you.
All right, thank you so much, Michael. I do have a question before I let you go.
Sure.
So how do we move these in like a pipeline so that I don't have to go? I mean, think of Flux, right? So when you have Flux, you think like you merged something and should be working.
Yep.
Right? I don't want to catch that when it's already merged. I want to catch that before the merge, so the merge fails. So yeah. What are your thoughts around that?
Yeah, and that's a good question. It's not a problem that we've addressed yet. So what we've got right now, and I won't show it off right now, but we've got a custom dashboard that we've built, and in fact, we've been collaborating with the Flux team on our dashboard a little bit. That presents a tenant view of what's going on in their namespace. that we highlight, here's the customization object since we're using to, has it applied successfully? Were there errors with it? And so if they do define an ingress that fails, yes, it technically Flux tried to apply it, but on their dashboard, they can quickly see that, and we highlight that error and kind of put it in front of them. So we don't have it quite yet that it will catch it earlier in a pipeline, but we at least have tried to give the right level of visibility when something does fail.
A question in the chat from Brandon. With OPA, can you allow users to create different namespaces in a multi-tenant environment, or does that break some of the auth logic?
Can we allow tenants to create their own namespaces? You probably, I mean, you certainly could, but you'd have to think about, okay, when you create a namespace, how do you grant authorization to that namespace? How do you make sure that that they're authorized to even use the namespace they just created? And then what sorts of protections do you put on that new thing? So you'd have to do quite a bit more thinking about what sorts of events or things do you do once that namespace is created. So as of our team right now, we don't allow the tenants to create their own namespace. They have to reach out to us, and then we set that up for them. The other hand, I'm forgetting the name of the tool, but there's another project that somebody just pointed to me to a week or two ago that basically allows you to run almost an entire virtual cluster within your namespace. And
that's virtual cluster. That's
okay, virtual cluster, yeah. and so that's, you know, if you really wanted to give people that level of ability to create their own namespaces or their own CRDs, and that, like, we don't allow our tenants to do that, then you would have to, if you want to do it right, you'd probably want to be looking at the virtual cluster kind of stuff there. So.
Thank you so much.